Okay, video number 3. Getting close to being done. Had to get my calculator ready. Okay, concept 25. How many times does the graph intersect the x-axis? Well, whatever the graph they give you is, plug it into y equals. It's in your calculator, press y equals and get it here. Plug it in, and then you can hit the graph button. Then you may see it, you may not. If you hit zoom, so hit the zoom button here, and then you can just hit the number 0. But I'll show you what it looks like. It says zoom fit, as in like, hey, I don't know where my data is, but I need it to fit on this screen. It'll then adjust this window for you to make sure you can see it. That might not always tell the same thing, because if it's like this and it's just barely over, you won't be able to really tell. So the best thing to do is hit the second button and then the window button. It says table set. We're going to go to the table, start at 0, and we actually want to count by 0.5, 1/2, because when we go look for, we're looking for y equals 0. Once I get y equals 0, that is a solution. And we want to make sure that even if it is here, like if that's, you know, -5 and that's -4.5, I want to make sure I see both, because otherwise it'll look like that. So anyway, this one crosses twice. This one, if it comes down and touches and only has one spot where y equals 0, that only is going to cross once or touch once. And if your graph is way up here or way up here, or if we're upside down and it's down here somewhere, we could have no solutions, or no times it's going to cross the x-axis. They might give you a graph and say, what point is the vertex? Well, the vertex is like the bottom kind of turning point. So this is x is 1, y is -2. If it asks for x-intercepts, it's where y is 0. So make sure that you don't do 0, -1. It's x and then y is 0. So you go over -1, up or down none, over 3, up or down 0. So those would be my 2 points. Again, though, if needed, if you don't have the graph, you can always plug into y equals and hit graph, and then kind of match up the points. This actually covers 3 concepts. If they want to know about the discriminant given a graph, it's pretty simple. A positive discriminant, remember the b squared minus 4ac, that means we are crossing twice and we have 2 solutions. A negative discriminant always gave us imaginary numbers, so we have no solutions. It's not going to cross at all. And when your discriminant is 0, it is a 1 solution. Come down and touch and go back up. Which graph matches the equation? Well, this will be probably the easiest thing to do is we'll go into y equals and type in whatever it is and hit the graph, and then look and see, like, maybe at the vertex point could tell you what's happening. And again, if it doesn't all fit on there, zoom 0, zoom fit will work. So for example, if I did like x squared plus 15 and I hit graph, I'm not going to see it. I saw that little flash right there that tells me something happened. But when I hit zoom 0, zoom fit, it's going to say, oh yeah, here's what's actually happening. And you got to be careful, because this right here is actually not the x-axis. And you can go to the table and find that out for sure. That's actually going to be y equals 15. We're not going to get any lower than 15. Passed it up. And if you're always wondering if the table doesn't show you, you can actually hit the window button and it'll say, we made the minimum 15. Well, if you want to make the minimum 0, then it'll actually show you what's happening. So now you can see this is a solid line for the x-intercept, and the other one was not. So just plug it in your graph, zoom 0, and whenever you're ready to go back to the The 10 by 10 Zoom 6, a Zoom standard. We'll get you back to 10 by 10. Okay, square root of a negative number gives an imaginary number. We'll call it I. So the square root of negative 1 equals I. The square root of negative 4, if you put this in the calculator, it's going to give you an error. It's going to say non-real. So when you have a negative number under the square root, just know that we are going to be dealing with imaginary numbers. When you add or subtract complex numbers, honestly, you can do this in the calculator. But it's not that bad. You just match up the real stuff with the real stuff and the imaginary with the imaginary. So it can be done in the calculator. It might be a little faster just to go, oh, 7 minus 3 is 4, and negative 5 minus 2 is negative 7, so 4 minus 7i. But if you want to do it in the calculator, make sure you do it exactly second and then decimal gives you your I. Make sure you do it exactly as you see it. Make sure that's a negative 3 and that is a minus 2i, because if you have it wrong, it might give you some sort of error. But it's the same answer. It can be done that way. Same thing with multiplying. Multiplying can be done in the calculator, but it's just foiling. The only thing is I squared is the exact same as negative 1. So when you FOIL and you go I times I squared, just like we would x times x is x squared, that I squared becomes negative 1. That negative 1 times that negative 15 is positive 15. And then just like what we just did, you know, combine the things that are alike. But 4 plus 3i times negative 2 minus 5i should get me the same answer. It can be done in the calculator. Again, second decimal will give you that I. Just make sure it is correct. And kind of going backwards here, if there's a minus sign, distribute the negative. So that would be like a positive 3 and a positive 2 before you combine your like terms. Again, square root of negative 1 is I. So when trying to square root a negative number and get an actual answer, basically we're just going to break this up. One of them is going to be negative 1. One of them is going to be the number, because negative 1 times that number gets us here. Well, then we could just look at square root of 25 and say, oh, that's 5. And the square root of negative 1, well, based on what's up here, we know that's I. So my final answer would be 5i. Well, if it doesn't square root nice and pretty, we're still going to break this up, but then we're going to factor this out. 50 divided by 2 is 25, divided by 5 is 5. So this is 2 times 5 times 5. Well, with our square root, we're looking for a pair of stuff. So that pair comes out to the very front. Negative 1 is still I. And notice that I is not inside my radical. I'm taking it out. But my square root of 2 that got left over, that's going to stay square root 2. This one's kind of crazy. Which one's equivalent to I to some crazy exponent? And they're going to give you like these 4 options here. I, negative 1, negative I, and 1. Well, honestly, knowing that I to the 4th power is 1, any multiple of 4 is just going to be 1 times 1 times 1 times 1 times 1 over and over and over. So what we can do is we'll take that crazy exponent, whatever it is, and divide by 4. So 68 divided by 4, 49 divided by 4, whatever. And it'll give us, in our calculator, 17, 12.25, 6.5, 31.75, or whatever it is. Then all you have to do is match up these decimals with these decimals here in blue, because if we divide our exponents by 4, 1/4 is 0.25, 2/4 is 0.5, 3/4 is 0.75, and 4 over 4 is a whole. So with no decimal, we know that it's 1. With 0.25, we know that it's I. 0.5 is negative 1. 0.75 is negative I. So you don't even have to use you can do I to the 68th, but it's going to kind of spit out something. Like it works for maybe smaller ones like that, but for some reason, oh, it doesn't even work for that one. Okay. I to the, let's go to the 9th. Man, my calculator is not liking this, and yours may not either. But either way, all we have to do is divide by 4 and match up. decimals. And that'll be the end of this video. There are 47 concepts, so we got 10 more on the next video and we'll be done.